Hey everyone, this week we're going to talk about one of the very first human-made chemical reactions, combustion.
Before we do anything, this is what complete combustion looks like. All right, so in this case, we're going to be using a Bunsen burner. So we're burning propane, so C3H8 is propane. It's going to react with oxygen from the air, and the products, if we get complete combustion, will be water, H2O, and CO2. This is the pattern you're looking for combustion. Whatever fuel you have, if carbon is present in your fuel, which it is a lot of times, you get carbon dioxide. If hydrogen is present in your fuel, you get water. That's the most important thing. Now, if you have other impurities in there, then you can get other chemicals. But as far as we're concerned, we're going to be worried about looking at burning mainly hydrocarbons, which is carbon and hydrogen. So if you have carbon, you get carbon dioxide. If you have hydrogen, you get water. This is called complete combustion. So this is when everything works perfectly and you have plenty of oxygen available to make it work right. When the Bunsen burners are set up properly, this is what complete combustion should look like. You can see the flame has a lighter blue color in the middle, and then there's very little yellow. You shouldn't really see any yellow. We might even be able to get rid of some more yellow here. See that? That's actually even better. So you should be able to get rid of pretty much all the yellow in your flame, and that's when the Bunsen burner is working as efficiently as possible. Now, Bunsen burners are not very complicated. There's a little needle valve that screws into the bottom, looks like this, if you can see that. And then obviously there's the tube coming in that brings our propane in. So propane comes in here, and you can see it just kind of goes in. The needle valve is going to go right here in the bottom. So we can put that in real quick. So this valve will adjust how much propane can go through. That little needle just goes up into the top, and you'll see, hopefully we can get in close enough, that there is a tiny little hole in the top of this brass piece up here. That's where the propane comes through, and that needle goes up into the top of that, into that point. So you can totally shut off the gas by screwing this needle valve all the way in, and that needle will go right into that point, and it'll stop all the gas from coming through. Then the other part of the burner is this top piece, which is like the little chimney here. I'm going to screw this back on, hopefully. There we go. Back on the top, and hopefully we can kind of show you. The propane comes up through that tiny little hole, shooting up through here, and then in the sides, it allows air to rush in the sides, so that the propane gas and the oxygen can mix as it goes up the tube, and then we light it up here at the top. What this means is, through the bottom valve, I have control of how much propane comes through, so I can actually increase the amount of gas, or if I go this direction, decrease it, and see I can make the flame smaller. Too small. And through this control, I can control the airflow. And here's what happens with the airflow. If I cut down on the amount of oxygen, you can watch how the flame changes, okay? Watch this. I'm gonna screw this down. I'm screwing it down so that it closes these air holes up. And watch what happens to the flame. See that? The flame changes and it turns into a yellow, almost looks like a campfire. See that? So not enough oxygen, that's what the flame looks like, and that's not nearly as hot. It's like 1,000 degrees cooler than when the Bunsen burner's working efficiently. And you'll see the nice blue flame come out. So watch this trick. So this is an evaporating dish, a little ceramic evaporating dish. If I hold this over the flame, watch this, okay? You'll see that comes out totally clean, right? Now let's check out something else. Let's close down the air again so that there's not enough oxygen for my fuel. Get this bright yellow flame, and we'll just use the same one. So this clean one, watch the difference this time. Just hold it over top of that flame for a second. And look, jet black. It's covered in soot. You can even see where my tongue was holding on to it. See that? Isn't that crazy? That's how much soot is coming out of that flame. So what exactly is soot? Soot is a product of incomplete combustion. When you don't have enough oxygens, if we limit the amount of oxygen, there won't be enough oxygens to combine with all the carbons and hydrogens. And you can even see, I just made this balanced equation real quick. You get products besides carbon dioxide. You get things like carbon monoxide, see, less oxygen attached to it, which that, by the way, is poisonous and can be very deadly. You get a lot of soot. There's your soot. It's pure carbon. So that black stuff you saw was just literally carbon coming out, and then you still get your water out of it. That's what happens with incomplete combustion. All right, everyone, I'm out here in the auto body shop with Mr. Jones, the auto body teacher, and I'm gonna show you another example of a combustion reaction. Okay, so let me tell you what we got here. So this is an acetylene torch setup. So what you have in this tank is pure oxygen under pressure, and in this tank we have acetylene. So the Bunsen burners burn propane. Propane was C3H8. We looked at the formula for that. 3 carbons, all single bonds, and then hydrogens are attached to the carbons around the outside. Acetylene looks like this. Notice the pattern of the reaction is the same. Here's our fuel, that's the acetylene. Reacts with oxygen from the air, or in this case oxygen from the tank, pressurized pure oxygen, producing carbon dioxide and water. It's the same formula on the ending of the reaction. All we did was change the fuel. And you know the acetylene gets a lot hotter than the propane. Part of that's because of its structure. The way it's put together, it's a triple bond between the 2 carbons. That bond is really strong. When we break that bond in combustion, it releases a lot more energy, which is why the acetylene torch can get up to over 5,000 degrees, whereas the Bunsen burners only get up to about 2,000 degrees.
We're going to turn on the acetylene, which is the gas side of this equation.
Yep.
I'm not the physics teacher, so it may not be an equation, it might be a formula. That is pure acetylene. Now, if I turn it down, you can see the soot coming off of that. See the soot? There's a name for those, but I'm not going to tell you what it is. And now we're going to slowly turn the oxygen. As you can imagine how extremely hot that is. If I turn the gas off, it goes out. Now, I'll show you what happens the other way around. If we get the mixtures, hang on, if we get the mixtures out of balance, too much oxygen, it goes out as well.
Mm-hmm. So they use these acetylene torches. You can use it for several things. You can use it to just heat up metal, like in the auto body shop. If a car comes in and it has a wreck and you need to straighten out the frame or something, you can heat the metal up to bend it. You can also use it to cut metal. So you'll heat the metal up so hot that it'll blow air through it or blow oxygen through it and cut right through thick pieces of metal. And you can also use it to weld and braze with. You gotta have some talent for that. So we're gonna show you how it can heat up this old wrench and bend it. That the wrench isn't really worth anything. So we're gonna heat that up and show you how you can bend something that you normally think of you can't really bend very easily.
All right, we always start out with the acetylene, and we're gonna bring it down. That's called a neutral flame. It's burning almost perfectly. Now this wrench is made out of tool steel. I know that's funny. They don't because they make it out of tool, but it's really, really strong and it's rigid. So I can't bend that. I'm gonna show you what the effect the heat will have on it. Pretty neat, huh? Don't touch that.
Yeah, don't touch that. That's super hot for us. See it glowing red?